Hi, I'm going to be walking you through a demonstration of the ThinWire Ajax Framework, which is a programming toolkit that can be used to build highly responsive and dynamic applications for the web browser. One thing that makes ThinWire unique is that you program exclusively on the server side against the ThinWire API, and then the ThinWire engine takes care of the rest. A couple of things to note about this demo are that the application you're about to see is one of a number of lending applications built by custom credit systems on top of the ThinWire framework. CCS was driven to create ThinWire because of the demands associated with building complex business-centric applications that run in the web browser. Typically, this application runs in 1024 by 768, but due to the video size constraints and so that you can make out the details of how the framework operates, we're going to demo this application in 640 by 480. As a result, you may notice that certain elements of the application appear scrunched. Also, due to video compression, mouse movements and screen transitions may occasionally seem jittery. You may also notice that while I walk through the application, that the style that the component widgets use makes the application appear like a Windows 2000 application. This is intentional because it makes it easier for users of the application since it offers an interface that conforms to the paradigm they are familiar with. However, ThinWire does support alternate styling. The last thing I want to make clear is that everything you are about to see occurs within a single browser page, without any page refresh and without the use of any plugins. Only the ThinWire JavaScript engine is sent to the client when you first launch a ThinWire application, and it is only about 115K without gzip compression or code compression techniques. If you apply such techniques, the size can be reduced to a third of that. After the ThinWire engine loads, only user action events and incremental update events are transmitted to and from the server. Now let's get to the demonstration. First, I'm going to pull up a search screen. Notice how I can drag around this dialog and it behaves like a traditional window. Also note how the dialog is modal. I can click on anything in the background. I can't click on anything in the background. Now let me search for something. Let's say I want to find a customer that I know has the letter H in their name. So I would enter H and click search. Notice how the content of the grid is loaded immediately and without any interruption to the user experience. In the results grid, you can see that there are multiple columns of information. You can resize the columns, and although it's not shown here, if you enable it, you can sort by a column, either ascending or descending by clicking on the header. Now let's say there are too many results, so I need to refine my search. I'll go to the search field and type HOM and then click search. Notice how the grid empties and repopulates with the new results almost instantly. So finally, let's say I remember the actual deal number associated with the application. So I just go to the deal number field and type 284. Notice how the logic on the screen was built to disable features of the screen upon recognizing that I'm now just entering a deal number. Further, since the OK button is now enabled, the ThinWire allows you to define a default button on the screen, I can just hit the Enter key on the keyboard to click the button, and there we go. The system is now loading the deal I specified. Now, in this application, the initial state of the deal is simply to display a tree that represents a hierarchy of everything that makes up a deal. It's worth mentioning that the tree component supports having an image associated with each tree item, and that you can set up lazy loading of tree branches by listening to the expansion of a tree node. Like all ThinWire components, the tree is 100% dynamic, so you can insert, delete, or add any nodes to the tree dynamically without having to redraw the entire tree. Now I'm going to show you a simple form within this application. This application represents its forms within ThinWire scrollable containers so that regardless of the screen size you run at, you can always access the information. But as I mentioned earlier, we're running at 640 by 480, so the form scrolls. A great feature of the drop-down component within ThinWire is that it's based directly off the grid component, and as a result, it has the features of the grid. Further, it inherits the same programming API as the grid, making the learning curve easy. Notice how the drop-down has columns just like the grid. You can also choose not to show the column headers for a drop-down if you want. Multi-column drop-downs aren't very common in web applications, but they're a great way for showing information associated to the record being selected. Now when I select an officer, notice how detailed information about the officer, such as email address and phone number, is immediately loaded into the fields on the screen. Since ThinWire applications are written entirely in a server-side language, you simply listen for text property change on the drop-down, and then you set the text property of the associated field with information that's appropriate. That's it. ThinWire automatically handles all the communication back and forth, as well as updates to the user interface. Now I want to show you one of my favorite features, the real-time edit masking engine that ThinWire offers. Anyone who has had to deal with the headaches associated with validating user form input and handling invalid input will appreciate the simplicity of this approach. Take the date field. It should accept the date in a 2-digit month, 2-digit day, 2-digit year format separated by slashes. When I try to enter alpha characters into the field, you'll notice the masking engine rejects my input. Taking it a step further, since the first 2 digits are a month in the range 0, 1 through 12, the edit mask engine prevents me from entering an invalid month, such as 21. The same applies to the day and year. Additionally, I only need to enter numbers for the value, and the edit mask engine will automatically add the slashes where appropriate. The same applies to the time field. It masks exactly the same. All you need to do in order to use the edit mask engine is to set the edit mask property of the text field component to the edit mask combination you need. We don't define how you must input a date, the time, or any other value. The framework simply provides mask characters that you can put together in any combination you need. Additionally, drop-downs that are set to allow editing also support the edit mask property and provide the same capability. A final note is that as a failsafe, the server has a second layer of validation that makes absolutely sure that the value entered conforms to the mask. In the event that it doesn't, the value reverts back to the last validated value. So now we're going to click the Save button. And one thing to note about the buttons in the framework is that you can have an image displayed on a button simply by setting the image property of a button component. The neat thing about this is that the image buttons do not appear differently from other buttons, and they behave the same, pushing in and popping out as you click them. We're going to go to the more complex screen here, the borrow info screen. And this screen uses a style API of components to change the background color of fields to indicate required values. Also notice that when I toggle the individual company radio button, the screen changes its appearance, hiding unnecessary fields and displaying other applicable fields. Another feature of our grids and drop-downs is that you can have checkboxes displayed, thus allowing a user to pick multiple items as needed. One last interesting feature of our grids and drop-downs is support for multi-tiered hierarchy. This allows the user to navigate a hierarchy of information rather than having to show a massive single list of items. Additionally, it's typically useful to build your tiered drop-down so that they load sub-tiers on demand, thus cutting down on the data set loaded on the screen. Keyboard navigation is also a major consideration, especially when you're talking about business process applications. That's why all the components in the ThinWire support keyboard navigation. For instance, I can use the arrows to navigate a drop-down and navigate through the tiers, hitting enter to select an item. Now let's take a look at our tab folder. You can switch to another form, and if desired, load the content of the tab dynamically upon activating a tab. It's worth noting that tab sheets can have images associated to them as well, just by setting the image property of a tab sheet, although this application does not leverage that currently. Additionally, menus also support having images for each menu item, as well as another neat feature, keyboard shortcuts. You can easily associate a keyboard shortcut with any menu item that will, upon typing a key combination, fire the click event of the menu item. So for instance, The search screen demonstrated at the beginning of this demo can be pulled up by hitting Ctrl-Alt-F. Notice that the menu item also renders with the keyboard shortcut displayed. Keyboard shortcuts can also be established on any component so that you can trigger any action you want. Hopefully this gives you a good understanding of the kinds of rich web applications that can be built using ThinWire. If you haven't yet visited our website at www.thinwire.com, please go there and check out some more examples and find out some information about our framework.